Hi everyone, this is Mr. Zarzak, and I'm going to show you how to get approximately 1 kilogram worth of mass to use in the Muscle Up Lab. Okay, so we say approximate, so anything like 900 grams to about 1100 grams would give you a good range, good enough for the lab. Okay, so your iPad is unfortunately not quite enough, but your iPad plus your cell phone is just about perfect. And if you want to use your cell phone for timing, you can take, if you happen to have like a graphing calculator, okay, your iPad plus a graphing calculator is just about a kilogram. So that's something you could use. If you happen to have some small weights lying around the house, a kilogram is 2.2 pounds, so 2 1-pound weights would be just fine. A lot of these are pretty popular, these 2.5 pound weights, so one of these would work for a kilogram as well. So this is just kind of what they look like, so when you know when you're digging for stuff. This size bottle of sports drink, which is 32 fluid ounces, anything in the range of about 32 to 36 fluid ounces is kind of perfect. Okay, so this would be just right for a kilogram. A couple of cans of vegetables like this normal size, so these are 15 ounces a pop. Okay, so something in that range, two of these together, you got yourself a kilogram. We found some pancake mix in our pantry. This is 2 pounds or 32 ounces, so this would also be perfect for using as approximately a kilogram. Okay, 3 cans of soda together, that's 36 fluid ounces, so that would be good for a kilogram as well. And if you don't have any of that kind of stuff, like these kind of standard size cleaning bottles, okay, so just find anything like this, and one of these is good for a kilogram. And then 2, this Murphy's oil soap we found is just about the right size. Okay, so hopefully you can find something that matches for what you need and get your 1 kilogram. All right, good luck everybody. Thank you.
Hey, this is Mr. Kim, and I'm just here to give you some tips and hints for trying to figure out how to measure forces and displacements for your curls and stuff. So for your lab, you gotta eventually somehow measure how far you're gonna curl up a weight. And so you have a weight possibly in your hands, curl up to your shoulder height there. So if you've got a 1.6 meter, use that guy, measure from your hand up to your shoulder. If you don't, you could measure just using some iPad cord cables and try to hold this bottom part down in your hand and try to figure out how far up your shoulder the iPad cord goes. Figure out that length there, and from that actual cord, mark that off and use your measure app to figure out how long that cord actually was to get your displacement for your curls on that exercise. For the actual force that you'll have, we've got a 1 kilogram mass here that we're going to curl 50 times. If you don't have one of these guys at home, and I'm guessing you probably don't, your iPad is actually pretty darn close to 1 kilogram. So if you want to curl your iPad with its case on, that's about the same mass as a 1 kilogram mass there. So I'm going to have my iPad in my hand, curl it upwards as well too, and you're good to go. 50 reps total. To convert from a mass to a force, always use your equation Fg equals mg. I think you'll be set for this part of the lab. All right.
Hey folks, this is Mr. Ritchie showing you how you can measure your displacements for the stair running portion of the Muscle Up Lab. One of the biggest things you need to worry about is the displacement from when you're starting your run up the stairs to the top. Now ideally, if you have a tape measure, you can just measure directly the height if you have some sort of a landing or some sort of a railing off to the side. If you don't have that, there's a couple of different ways that you can measure that displacement. The best way you can do that is to measure the displacement of just one of the steps and then multiply that displacement by how many steps there actually are. So you can either measure it directly with your tape measure like this, make sure to convert to meters, and then multiply by the number of stairs that you have. Or if you want to use your iPad charging cord, you can figure out how high one step is, take that displacement, you can lay it on the ground and use your measure app. If you need to use some sort of a tracking piece on the ground for your measure app, you can take a piece of paper, rip it up, you can place it on the lengths that you just measured, and then multiply by the number of stairs that you have. So that's a nice little tip for you guys to use for the stairs. For the displacement, obviously for the force that you're going to be measuring, that's going to be the force that you have to apply to lift yourself up against the force of gravity. So that's going to be your weight in pounds, and then multiply by a conversion factor of 0.45 to get to kilograms, which then you can use with acceleration of gravity to find Fg. Fg equals mg. So hopefully that's helpful for you guys with your stairs portion of the lab. Good luck.
Oh, hey, didn't see you there. So you need some help with figuring out how high you can jump, huh? No problem. all you need to do is have the ability to mark on your wall a start and an end point of your jump. Whether you're using some sort of marking tool, or you're using some sort of tape, or maybe even a Post-it if you have it available. Let me show you how it works. So you're gonna just stand up next to your wall nice and straight, reach up as high as you can, and put a mark on the wall. Again, if you have something permanent, like a permanent marker, a pencil, a pen, something like that, that's gonna leave a mark on your wall, put a piece of paper on the wall there maybe, okay? And you'll go ahead and put your mark in. Then go ahead and just jump. You don't wanna do a crazy high jump. Remember, you're gonna be jumping continuously for a period of time. It's gonna be harder and harder and harder to maintain that jump the longer you do it. So do something that you're just comfortable with, okay? So here's my start mark, 3, 2, 1, okay? And then you can see I have a mark here. It's kind of a stray mark, but again, my mark starts about there. So how high did I jump? Well, that distance. Now, if you have the ability to measure it with a meter stick or a ruler and you can measure in metric, great. But if not, we're gonna use the Measure app on our iPad. Okay, so we need to get a straight line measure of that distance that we can translate to our Measure app on our iPad. So we're gonna use our power cord. So I take my power cord, I mark my start and my end points of my jump that I marked, and this is approximately how high I can jump. Go ahead and measure that with your Measure app, and you're all set. Okay, let's say you have a piece of tape, a couple pieces of tape, or a Post-it. The same idea applies, right? Put a Post-it down on your wall for your start height. Bam, there you go. Grab another Post-it, reach up, 3, 2, 1, jump, throw the Post-it down, measure that distance, if that works for you, with your cord, and then use that cord length with your Measure app to determine your distance. If you have somebody to help you at home, okay, just have somebody watch how high you jump. Have them get down at eye level and jump, right? And then they can eyeball how high you jump using, again, a cord, and then they can translate that cord to your Measure app on your iPad. Okay, so these are just a couple ideas. If you have a ruler at home, again, it's very easy if you have a ruler and somebody to help you to just do it that way as well. Good luck, get jumping.
1001, 1002, 1003. Oh, hi there. We were just doing some push-ups, getting ready for our Muscle Up Lab. Here's how you're supposed to measure in the Muscle Up Lab. All right, physics students. So I actually am lucky enough to have two people helping me, my son Barrett and my daughter Addie. But if you're not that lucky and you're at home and you're just by yourself, you can still make this work. So what you want to do is find any measuring device whatsoever, put it on the wall. So for me, I have a tape measure here. If you have a ruler, that's fine. You can just kind of use the ruler 3 times if you need to. But for the push-up, like you're not going to go any higher than a meter, right? So any type of like measuring device at all, and even without a measuring device, you still have the Measure app on the iPad too. So don't forget about that. If you need to just mark where on the wall you were at the beginning of your push-up and at the bottom, and then just use the Measure app vertically to be able to figure out that distance. It's still good enough for what this lab needs. Now, when we do the push-up, my assistant is going to try and put the sticker on the wall where my original push-up is by the shoulder height. Okay, so like, let's go ahead and show that, Addie. You ready?
Yep.
Okay.
So it's like to
All
20,
right, put the sticker on.
26 feet.
All right, then I'm going to go down into my push-up position all the way at the bottom, and my assistant's going to go ahead and put another sticker.
11.
Got it?
Just this one.
Okay, and now we actually have a difference in how much height I'm going to be doing for that displacement as we change in potential height, potential energy, as well as doing work equals force times displacement. This is the amount that I'm going against gravity, and that's what I want to include in my calculations. Okay, so 2/3 of your body weight. You're not actually lifting your whole body weight when you do a push-up. And remember, if you have something in inches and not a metric, just go ahead and throw it into Google for this lab, and that's fine. And just make sure, if you can, if you really want to impress, use the factor label method and try and show it on the lab itself. All right, guys, that's it for us.